Quotient of a power is what we're doing today. Way this works, you got something, a base, A, with an exponent, M, and written as a fraction, that's division, the same base with a different exponent. Yesterday and Monday, we did multiplying, and what was the rule when you multiplied things that had the same basis? What did you do with the exponents? You add them. The opposite of multiplication is division, so we'll do what with the exponents? We'll subtract. That's all right. M, and it's always going to be top minus the bottom in that order. Be careful of that. The addition, it really didn't matter which way you added them. Okay, but with the division and you subtract, it's always got to be top minus bottom on the exponents. That's exactly right. Okay, so x to the 7th over x cubed, something easy to start with. Same base, right? X's, the top, or the numerator has an exponent of a 7, the denominator has an exponent of a 3. We subtract those, x to the 4th. If we have a number as the base, here we have a -3 as the base. The -3 is the base of the answer, and our exponent on that -3 would be 5 minus 2, 3, positive 3. 5 minus 2, top minus bottom. Make sure you do it in that order because we will get into negative exponents next week, and there's things we got to do for those. So make sure it's top minus bottom. Then you can't do that. And we'll get into some of those in just a second. I promise. So, -3 to the 3rd power, that's exponential form. What's standard form for that? Which is -27. So there's exponential form first, and then standard form after that. What you're going to do there. Most of everything we'll do today is going to be standard form. The numbers don't get too large, and we just want to simplify as much as we can. Example C. Sometimes they'll throw this kind of weird one looking thing at you, and they'll put x to the 6th times 1 over x to the 4th. And it looks weird, and it's a multiplication problem, but you're multiplying by this fraction. And anytime I'm multiplying something times a fraction, I like to write this as a fraction. So how can I write that as a fraction? I can put it over 1, right? X to the 6th over 1. And then the rules for multiplying fractions are you multiply numerator times numerator, denominator times denominator. What's x to the 6th times 1? It's just x to the 6th. And on the bottom, 1 times x to the 4th, just x to the 4th. Now we've got it written as one fraction. And what are the bases the same? So what do we do with the exponents? Subtract them. So it'll be x to the 2nd. Yeah, good job. Remember, it's always top minus bottom. Okay, numerator minus denominator. Sometimes they'll throw something like this at you. X to the 4th times x to the 5th divided by x to the 3rd. Why can you do that? That's correct. Because they're multiplying on the top. So it's like an order of operations problem that you do multiplication and division left to right, or, in this case, it's up and down. So we're going to do that multiplication first, and that's going to be x to the 9th over x cubed, and then do your division. Ends up being x to the 6th. Good. It is. Again, if you know the rules from Monday and Tuesday, it makes it much easier. Okay, so here we did the numerator part first. Got x to the 9th. 5 plus 4 is 9. Because these are multiplying together, the rule is to add the exponents. Then we take that and say, oh, now it's a division problem. 9 minus 3 is 6. So we do it in that order. Multiply first and then divide. Because order of operations works that way. Left to right, actually. Top to bottom in that case. A little stronger problem here. X to the 10th times x to the 5th over x to the 7th times x to the 6th. Add the top and the bottom first. So x to the 10th and x to the 5th is x to the 15 and x to the 13 on the bottom. And now what with the exponents? Subtract. 15 minus 13 is, there you go. Okay, so we're doing it again. We're multiplying first. Since they got the same bases, our rule is add the exponents. 10 plus 5 is 15. And then 7 plus 6, because we're multiplying on the bottom. We're doing that multiplication first. That's 13, and then we subtract those two. And get x squared as the final answer there. Let's throw multiple letters in there. Shelby had asked about this, so I'll be glad to oblige her in putting some problems in with extra variables. Don't get much more difficult, though. Go ahead, Jen. Yes, absolutely. Very good. 6 minus 2, x to the 4th. 3 minus 1, y to the 2nd. There you have that. That's the answer. It is that easy. It really doesn't make it that much more complicated. Now, we're going to get a little bit more complicated. Today. And tomorrow. It's okay. It's still, let's throw this problem out there. X squared, y to the 5th, over x to the 7th, times x to the 8th, y over y squared. Okay, so we're getting a little more complicated problem here. But here's the idea. What do we need to do first if it's a multiplication problem? Add what?
2 and 8, 5 and 1.
Okay, very good. When we multiply first, remember we're multiplying first before we can do that division. So we're going to multiply numerator times numerator. And Shelby said we're going to add the 2 and the 8 together. Why can we add those two numbers together?
They got the same base.
They got the same base. So when we multiply x squared times x to the 8th, we get x to the 10th. Because these two have the same base. We add because we're multiplying. And then the y to the 5th and y to the 1st. That's right, y to the 6th. On the bottom, do these have the same base? No, so we can't add the exponents for them. So we just copy them over. X to the 7th, y squared. Perfect. So not incredible. It looked really nasty to start off with, but it's really not that bad. If you follow those rules of multiplying first, take care of your exponents there, and then divide. Okay, that's always going to be how you're going to do that. Okay. Let's throw some numbers. We will. We're going to do plenty. Got several examples today. Let's throw one in there with numbers involved. 3x to the 5th over 6x squared. And we'll get back to some more of the multiplication problems in just a minute. True. Doesn't really apply here. Doesn't help none. Now, go ahead. Okay, it gives us x to the 3rd. Okay. What about the 3 and the 6? No. What operation is this? It's division, but that's a fraction, isn't it? Can we reduce 3 over 6? How? 1/2. 3 goes into itself 1 time and into 6 2 times. We're left with 1 to the third over 2. So the numbers that are in front, the regular numbers, if they don't have an exponent, then there's no exponent rules to follow. You simplify them like you would a normal fraction. 3 over 6 reduces to 1/2. No, because there's not an exponent to deal with there, because they're different bases. This is a 3 and that's a 6. If they were both 3s, then yeah, I could put an exponent there and work with it from that. We'll get to some where there needs to be a 1 put on it, depending on what rule needs to be applied. Changes that. Here we have 8x squared y to the 5th over 14x y to the 3rd. What about the 8 and the 14? Are they the same base? Definitely not. So how could I reduce 8 over 14? Divide them both by 2. They're both even numbers, right? So 8 divided by 2 is 4, and then 14 divided by 2 is 7. And then what do I do with the x's and the y's? 2 minus 1 is 1. 5 minus 3, 2. Notice that I'm always putting that answer in the numerator, in the top part of the fraction. That's what you need to do. Do not put it in the bottom part of the fraction. We won't get into that until next week, because that implies the use of some negative exponents and things like that. Shelby? Okay. No, they should always be in the top. They should be in the top of the fraction once you finish simplifying. Once you finish simplifying, the variables should be in the numerator of the fraction. Okay, especially today. We will get to some later in the chapter that don't do that, but with the basic rules that we're going through in these sections, they will always be in the numerator.
What did you do with the X and Y on the bottom?
I subtracted their exponents. So when I subtract, that variable's gone. X squared minus over x to the first, 2 minus 1 is 1. That's that x. These two turned into that. And then these two turned into that. So the bottom one's no longer existing, because we've taken those two and made what they would be together out of that. Yeah, you can. If it's a 1 on the bottom, if it turns into a 1 on the bottom, let's look at the next one. I think you'll 4x to the 3rd squared over 8 x to the 5th. Okay, so this kind of goes where Blake was going a second ago about the 1 exponent and all that stuff with the numbers. So this is starting. We've already been using some of our rules from the last couple of days. This is using a different rule from the last couple of days. What happens with those parentheses and the exponent on the outside? Multiply to what? Okay, so what exponents are on the inside of the parentheses? 1 on the 4 and 3 on the x. So that ends up being 4 squared x to the 6th. Then on the bottom, we still got x to the 5th and 8.
So you just multiply the 2 and the 1, and you got the 2 and 3 and 2 and 6.
Yes. So it's a distributed property thing that we've done the last couple of days. With the parentheses and an exponent on the outside, you multiply the exponents. Okay. Once you've done that step, because we're following order of operations here. Parentheses first. Well, we went to the parentheses. There wasn't anything we could do inside of there. The next step in order of operations is exponents. For the top part, there's an exponent to deal with. So we did that part next. The next thing in order of operations after exponents is multiplication. Well, you got to use multiplication to figure out what 4 squared is, right? It's 16. And then you reduce the number, because after you've done multiplication, you do division. 16 and 8 reduces. 14 squared. 4 squared is 16. And then I just carried the x to the 6th over and just brought this all over here. Didn't change anything in the denominator. Okay. So here we have 16 and 8 are both divisible by 8. 8 goes into 16 twice, so that's 2. And it goes into 8 one time. So technically this is 2 over 1. It was there at the beginning. So the bottom part I haven't done anything to it. I'm just copying it every time. Okay. 8 goes into itself once and into 16 twice. So technically this is 2 over 1. But do we ever have to write it over 1? You know, if we're reducing a fraction? No, if it goes evenly, it's just 2. And then x to the 6th and x to the 5th make x to the first power. Because 6 minus 5 is 1. Technically, all of that's over 1, but we don't ever write it when it is. And here, this big ugly problem we started with turns into 2x using simplifying. Rule from yesterday. Still yesterday. Now, it didn't get to today until here. Okay, so this is the rule from yesterday. Multiply exponents. 16 divided by 8. 2. 6 minus 5. 1. That's where I'm getting those. Let's look at another one similar to that. 3x to the 5th, y to the 3rd, to the 4th power, over 3x squared, y to the 3rd power. This one's got parentheses on numerator and denominator. What's that numerator turn into? What's the exponent on this 3 right there? It's a 1. So it ends up being 3 to the 4th power, x to the 20th, y to the 12th. Because the rule is if it's a parentheses with an exponent outside, it multiplies to all of the exponents on the inside. Okay, that's the rule we've been using for the last 2 days. On the denominator, what's the exponent on that 3? 1. What's the rule for parentheses and an exponent outside? Times every exponent on the inside. So it ends up being 3 to the 3rd, x to the 6th, y to the 3rd, because that y had a 1 exponent as well. Now we simplify from there. Okay? Are these the same bases? Can I do exponent rules with that? 4 minus 3, 1. 3 to the 1st power. What do I do with these? Subtract 20 minus 6. X to the 14th. 12 and 3, 9. You're done. I could, but I end up having to divide 81 by 27. And who does that in their head? Not many folks. But doing the exponent rules, I did 4 minus 3 and I got 3 to the 1st power. We can all do that in our head. Right? Most of us cannot. I'll say I can't do 81 divided by 27. That's not a normal division problem that you do in your head. But 4 minus 3, that's a normal math problem you do in your head. 3 to the 1st power, that's a normal math problem that everybody can do in their head. Okay? So using the exponent rules is possible here because they have the same basis. We couldn't do that here because these didn't have the same basis. This was a 4 base and this was an 8 base. So we couldn't do that there. That's why we had to multiply that number out. So if the bases aren't the same, you got to multiply that number out. Shannon.
But if you do 81 and then
27. It would still reduce to be 3. That is correct. It still ends up being the same answer. Change it up just a little bit. Got an entire fraction in one set of parentheses with a 5 on the outside. Technically, this is the same rule that we used yesterday and Monday. 2 times 5 and 4 times 5. Every exponent on the inside gets that exponent that's on the outside multiplied to it. So that's x to the 10, y to the 20th. Can I do anything after that? Why not? Not the same base, so I know I'm done. That was very simple. Let's get the one that's not. Because you're smart. And I believe in you. That's what I'm supposed to tell you. I do. I really do. I think you guys are smart. Maybe a little unmotivated, but you're smart. Okay? So here we have a much more complex fraction. Got a lot more stuff in it. But what does every piece in it have? An exponent of some sort. What's the exponent on the 4? 1. What's the exponent on the 5 in the bottom? The x in the bottom. And a 1. What does this 3 that's on the outside do to everybody? Multiplies to every exponent on the inside. We can do that. 4 to the 3rd, x to the... What's on the bottom? Yeah, all of them have a 3 exponent now. Except for the 4 and 5, because they're not the same base. I've got to actually work out those numbers. Because these are not the same base, I need to work out what's 4 to the 3rd power. What's 5 to the 3rd power? 4 to the 3rd power is 64. 5 to the 3rd power is 5 times 5 is 25 times another 5. 5 quarters is $1 a quarter. 125. All right. Then what do we do with the x's? I already said subtract. So subtract those exponents on the x's. 6 minus 3 is 3. Where does the x cubed go? Numerator. Thank you. What about y? It also goes in the numerator. Thank you very much. Good job. So we have 64x cubed, y to the 6th, over 125. 64 and 125 don't share anything. You can't. And
If I would have had to have simplified that, it would have not been good.
got what part?
All of it.
Well, the part written in black, it was the original problem. Okay. Then when we looked at it and said, if it didn't have an exponent written, we're going to write 1 there. So that's why we put a 1 on everybody. The rule when there's parentheses with an exponent outside is to take that exponent and multiply it to every exponent on the inside. Okay. So that's how we ended up with 4 to the 3rd. 2 times 3 is 6, so that's the x to the 6th. 3 times 3 is 9, that's the y to the 9th. On the bottom, 3 times 1 is 3 for all 3 of them. So that's how they all ended up with the 3rd exponent. The x to the, or the 5 to the 3rd, x to the 3rd, y to the 3rd. Then, since these numbers are not the same base, the 4 and the 5, we just work those numbers out. 4 times 4 times 4, 64. 5 times 5 times 5 is 125. Okay? So that's how we got the numbers that are in the front. To get the x and the y, we subtract 6 minus 3 is 3. It always goes to the numerator. Okay? 9 minus 3 is 6. it always goes to the numerator. And that's how we ended up with that. It's got to be a step-by-step thing. X squared over y to the 5th times y to the 7th over 2x squared. Now, I won't get there today. We only got like 3 more. So we're getting back to the multiplying ones here. So again, we got to follow order of operations because we're in a math class. And math classes follow order of operations. Okay? So parentheses first. I look inside of these parentheses. Can I simplify that any? No. So then I have exponents. Parentheses exponent. Please use my dear Aunt Sally, that thing. So 5 does what to the exponents on the inside? Multiply. So that turns into. Good job. Don't stutter, Shelby. You get behind. I know I can't either. It's okay. Now, this one, is there any exponent work to do on this second fraction? No. So I'm just going to copy it down because there's nothing to do on it. Now, we've done parentheses, we've done exponents. What's next in order of operations? Please, multiplication and division, left to right. Well, there's nothing I can do here division-wise. So the next thing is multiplying left to right. So I multiply top times top, bottom times bottom. X to the 10th, y to the 7th. On the bottom, 2x squared, y to the 5th. All I did was rearrange it into one fraction with the x's in front and the y's in the back, just so it's in alphabetical order, so I don't get a twitch going or something.
So you did one top, but you didn't.
Right. I didn't change anything by multiplying because I wasn't adding or subtracting any exponents, and I didn't have any numbers combined.
So you can do back to
Good question. What else is up here? There's a 1 there. Does 1 and 2 reduce? No, so that 2 is going to be hanging out the whole time. He's in the answer. It's okay. Technically, there's a 1 up there. If it makes you feel better, it's a 1/2. Okay. Now, what happens with the x's? So that'd be x to the. Where's it go? In the numerator, x to the 8th. What about the y's? Seven minus 5 is 2. And it goes in the. Go ahead. Finish it. Numerator. Again, we're following order of operations the entire time. So we got parentheses, exponents, multiplication, division. We're not dealing with any addition and subtraction in these sections anyway. So other than with our exponents, and that's a part of the multiplication step. None of them. They're really not that hard. It's the same thing. It's just problems. All right. So here we have each fraction having parentheses on it.
You multiply that, and then you cut that. And
Okay, be more descriptive than that, and that.
My hands are never mind. Never mind.
I don't see a doctor about that. So what's the exponent on the first fraction? Is there anything I can do to simplify the inside? No, so I don't. What's the exponent on everybody on the inside? 1, 1, 1, and 1. What happens with the 1s and this 3? You multiply by the 3. So it's that to the 3rd, that to the 3rd, that to the 3rd, and that to the 3rd. That's a lot of that. Yeah, 2 to the 3rd, x to the 3rd, 3 to the third, and y to the third. Is there anything that I can do to simplify this parenthesis?
No.
No. What's the exponent on the 16? 1. What happens with the 2 that's on the outside and the 5 and the 1? You multiply. So it's y to the n, 16 to the second. Okay? Now, multiply across. 2 to the third is 8. X to the third, y to the 10th. 3 to the third is 27. 16 squared, Dustin, you said how much it was? 256. And then 256 times 27, everybody knows that, is 6,912.
I did not.
Yeah, I didn't either. I worked this problem last block, so. All right. Now,
Where did you get that 8 from?
that 8 came from 2 cubed. 2 cubed is 8, so that's where that came from. X cubed came over, y to the 10th came over. Here, 27 times 256 is 6,912. Y to the third, and then there's nothing here to bring over, so I'm going to bring the y to the third over with me. Now it's the simplifying step. 8 and 6,912. They're both even, so I know it's going to reduce some. Here's the trick to reducing things that have one really small number and one really large number. Think about what are the factors of 8. So what numbers go into 8? 2, 4, and 8. Start with the biggest of those. Does 8 go into 6,912?
Yeah.
How many times?
A lot. Well, I don't know.
8 goes into 69 8 times with 5 left over. 8 goes into 51 6 times because that's 48 with 3 left over. 8 goes into 32 4 times, 864 times. All right. Not much. It doesn't pay very many bills. All right. Now, what happens with the x cubed? There's not another one to go with it, so it's just going to come over to the party here. X cubed.
What about the 8?
It was reduced. We divided 8 by 8, and technically there's a 1 up here.
Oh, okay.
Because we divided this by 8 and this by 8. What about the y's? Y to the 7th, 10 minus 3. Where does it go? Numerator. Beside the x cubed. Good job. One more problem. All right. Last problem. Okay. 5x squared y to the third over 10 squared times parentheses, whoops, smaller set of parentheses, 10y squared cubed over 15x.
I got a quick question.
Yes, ma'am.
Why do they call it 3 cubed? Like, I don't understand that.
Because 2 is squared.
Okay, but why is
2-dimensional?
It-
3-dimensional.
Oh!
It does relate to that because to find area, it's square units because it's 2 dimensions, length and width. When you talk about volume, it's 3 dimensional.
Okay.
Length, width, and height.
Got it.
Good job.
I can be smart when I want it.
All right. Now, let's see if we can go through this problem.
You multiply 2 times 1, and 2 times 2, and 2 times 3, and then 2 times 1. Look at it.
Why would you?
You could. Following order of operations, guys. What happens first? Parentheses. So can we reduce anything in these parentheses?
Can you do the 5
Yeah, absolutely. It'd be a lot easier because I'm getting a smaller number, right? So 5 and 10 reduces to be what? 1 and 2. So it's 1/2 with an x squared and a y to the third. Okay? And then you apply that exponent. So it ends up being x to the... No. X to the 4. 2 times 2 is 4. Y to the 6. Good. What's on the bottom? No. 2 to the 2. What's 1 squared? It's 1. Remember we reduced the 5 and the 10. If you didn't reduce, you're going to have to reduce at some point. I would rather reduce with smaller numbers. Because 5 goes into itself 1 time and into 10 2 times. That's what I was doing there. Yeah, 1 squared is 1. Technically, there's a 1 here. But it doesn't change anything that's not there. Yeah, you can put it there. It's fine. Okay? Second fraction. 10 to the third and y to the 6th. No, because the 10 is inside of an exponent problem. You can't do division until you've done exponents. You have to follow order of operations. 10 to the third, y to the 6th. What is 10 to the third power?
100. No. It's like 110. No, 1,000. I got it.
1,000. Now, the next step, what's 2 squared? It's 4, right? So that's really 4 down there. Okay. Now, I'm going to multiply across x to the 4th, y to the 12th, and then 1,000 in front. On the bottom, I've got 4 times 15, which is 60, and then an x. 4 times 15. 2 squared is 4. 4 times 15 is 60. Okay. And now we want to reduce. So 10,000 or 1,060 are both divisible by. I'm going to go bigger. 10. 20 goes into 60 how many times?
30.
3 times. How many times does 20 go into 1,000? Not 500, but 50. 50 times. So that's 50. True. All right. What about the variables? Okay. So be x to the where at? Good. 50 came from dividing by 20. 20 into 1,000 is 50. 20 into 60 is 3. That's where those are coming from. And there you have found the simplified version of example B.
Are we done?
It's not bad.
I got all of them right. Oh my gosh.
It's not that many. Just do 3 through 45 odd. Don't worry about 49. It's pretty confusing. I ended up just doing it for fourth log. So.
Are you typing out plans?